Hello everyone. This video is on Knewton Alta assignment, section 2.1, part 2, called Distance and Midpoint Formulas. So in this video, I'm going to be going over this particular Knewton Alta assignment, or at least a version of it. Please understand that the questions I see in this video may not be exactly the same questions that you see when you work on the assignment yourself. But the objectives are the same, so the questions should be similar to what you're seeing, and I'm hoping that watching me go over these examples here help you in some way when you're doing the assignment on your own. Alright, so here's the assignment page. You won't see the word preview, you'll just see the title. You got your mastery bar telling you how far along you've gotten. You can view all the objectives for this section, this assignment, it looks like there are just 2 of them. And under the current objective, right, there's a question related to that particular objective. And at the bottom of each question, you should see a few buttons. There's the feedback button, which if you see a typo in the question, something's wrong with the question, or even the answer explanations, you see something wrong, doesn't seem right, send feedback to Knewton, tell them about it, and hopefully they'll address it and fix it. You will not see the instructor cheat button. Right, that's only for me. But you will see the more instruction button, which is very useful. If you're struggling with something, right, if you're on a particular objective and you're having trouble remembering how to work on problems related to that, or you're struggling with a particular question, click on more instruction, and you'll be taken to reading or some videos or both related to that objective, and then you'll also be given questions related to that instruction. And you can get through the whole assignment by doing this. You can click on more instruction for every single new question you come across and finish the assignment like that. It might take a little longer, but it's still doable. Nothing wrong with it. Alright, so let's get into this. Now the first objective is use the midpoint formula. So it says here, drag the point M below to the midpoint of the points 3, -7, and -1, 2 shown below, right? So here's 3, -7, and over here is -1, 2, they're labeled. You got a segment connecting them, and we're asked to move this point M around, right? Drag this around until we get to the midpoint. Right. Now the midpoint is the point that's exactly halfway, right? Exactly dead in the middle between these 2 endpoints. Alright, so I want to talk about the midpoint formula. Let's go to my paper. Alright, so suppose I'll just make a very rough sketch here of the Cartesian plane, the XY coordinate plane. Now suppose I have 2 points, say this point here, I'll just call it, point A, and this point over here, doesn't matter where it is as long as it's not the same point, point B. And I'll draw a segment between them. Right, a segment connecting them like this. Right, there's a segment connecting points A and B. We're asked to find what's the point exactly in the middle, right, exactly halfway between points A and B, these endpoints. That's the midpoint. Alright, well, let's talk about the coordinates of these endpoints. So say point A here has a y coordinate of of, I'll call it y1, and an x-coordinate on the x-axis of x1. Right, so this point has coordinates x1, y1. That's point A. And then this other point on the other end, point B, say it has an x-coordinate of x2 and a y-coordinate of y2. And so point B has coordinates x2, y2. To find the midpoint is actually pretty simple in my opinion. You just find the number that's exactly halfway between the coordinates. So like on the x-axis, how do you find a number that's halfway between two numbers? You take their average. You add them up and divide by how many there are. Well, there's only two of them. There's x1 and x2. So for the midpoint, you take the average. You take x1 plus x2 and divide this by 2. All right, this is the average or the mean of the x-coordinates. Of the endpoints. Right, points A and B. So that will be the x-coordinate of the midpoint. Right? And so here is the point I'll call M for midpoint. Right, so that point there on that segment should be, again, exactly halfway between A and B. So the distance from A to M is the same as the distance from M to B. That's a little tick mark saying that those segments are congruent, right? A to M and M to B. And the same thing goes for the y-coordinates. If you want to know the y-coordinate of the midpoint, just simply find the average of the y-coordinates of the endpoints. So y1 and y2, the average would be y1 plus y2. Right? Add them up and then divide by 2. So again, this is just the average, I'll just put AVG, of the y-coordinates of the endpoints. Very simple. All right, so M, right, the midpoint, if x1, y1 and x2, y2 are the endpoints, then the coordinates of the midpoint are x1 plus x2 divided by 2, right, the average of the x-coordinates of the endpoints, comma, and then the y-coordinate of the midpoint is y1 plus y2 divided by 2, the average of the y-coordinates of the endpoints. And this right here is what they're calling the midpoint formula. Okay, so the example they gave us, right, the question we're asked to figure out is the following. I'll draw the picture they have. They have negative 1, 2 as one of the endpoints. Right, there's an endpoint, negative 1, 2. And then 3, negative 7. Right, 3, negative 7 as the other end. And there's a segment between them, a segment connecting these. Like that. All right, hopefully it's visible. And we're asked to find the midpoint. All right, well, the points that we're given, again, are negative 1, 2, and 3, negative 7, right? These are the endpoints. And if I want to label them, this will be x1, y1, and x2, y2. All right, so the midpoint, according to what I wrote on my previous page, I'll call point M, is the average of the x-coordinates, so negative 1 plus 3 divided by 2. and then the average of the y coordinates, 2 plus negative 7, or 2 minus 7, right? 2, or negative 7 plus 2, doesn't matter, divided by 2. So the x coordinate, negative 1 plus 3 is 2, divided by 2 is 1. 2 plus negative 7 is negative 5, divided by 2, negative 5 halves, or negative 2.5. So 1 and then negative 2.5, right? So about here, negative 2.5, negative 5 halves. There's the midpoint. And that should be the same distance from both ends. Right. So we're going to plot this point. Right? I'm going to move that point on our graph to the point 1 comma negative 2.5, or negative 5 halves. So back here, I move the red point here to 1 on the x-axis, and then down 2.5. Down 2, down 2.5. There it is. And you see that? It's on the segment. And if you look at it, it does look like, and you could verify with the, we'll learn the distance formula in a second. But if you know the distance formula, you could also verify that the distance from negative 1, 2 to 1 comma negative 2.5 is the same as the distance from 1 to negative 2.5 to 3 negative 7. All right, I'll submit. Great. And again, it'll tell you if you're right or wrong. And then there's always going to be some sort of answer explanation. Please read through these, whether you're right or wrong. Right? If you're right, just glance at it. Make sure you're right for the right reasons. That you didn't just get lucky and guess. That you understand why you were right. Or, they might even do something in an alternate way that you like better that you could use in the future. And definitely read through the answer explanations if you got it wrong. Right? Try to figure out where you went wrong, why you were wrong, and then fix that mistake in a future question that's like that. All right. Next question. All right. So we're switching objectives and use the distance formula given 2 points. So here we're trying to find the distance between 2 points on the coordinate plane. All right, and if you end up with a square root, a radical, they want you to simplify that radical. So I'm assuming you know how to do that. If that comes up, I'll show you how. Right? But if it comes up. All right, so what I want to talk about now here is the distance formula. The distance between 2 points on the Cartesian plane, or the xy plane. All right, so once again, I'm going to just make a rough xy plane, Cartesian plane. Here's a point, and here's another point. Just picking 2 random points here. And again, I'll call this point A, point B, and I want to know the distance from A to B. Right? So basically, again, I'll just draw a segment between them. How long is this length? How long is this segment? Okay. Well, if you remember the Pythagorean theorem, finding a length, a distance between 2 points should be pretty simple. So imagine I'm at point A, and I only travel left or right. So I'd have to travel to the right until I get underneath point B, and then I can travel up and down. Right? And then I go up until I get to point B. And what I've just created here is a 90-degree angle, and this is a right triangle. What I've just shown, with the dotted lines and the segment we're trying to find the length of. What I've just created is a right triangle. Now, hopefully you recall, like I said before, the Pythagorean theorem. if you have a right triangle. Now, a right triangle has a 90-degree angle in it, like the picture I've drawn up here. Now, the two sides that form the right angle are called legs. So let's say this is leg 1 and this is leg 2. And then the side that's not forming the right angle, the side that's opposite the right angle, the longest side of the triangle is called the hypotenuse. Sorry if this is tiny, but hypotenuse, that's an S, Hypotenuse. So if you have a right triangle, and this is for right triangles only, this Pythagorean theorem, then leg 1 squared plus leg 2 squared will be equal to the hypotenuse squared. All right, and you may have seen this as a squared plus b squared equals c squared if you call the legs a and b and the hypotenuse c. This is going to help us a lot right here. So all I need to do now is figure out, using the coordinates of these points, what's the lengths of these legs? Because if I know the lengths of the legs, I can find the length of the hypotenuse, and that's the distance between A and B that we're looking for. So for A, let's say it has a x coordinate of x1 and a y coordinate of y1. And then for this other point, say it has an x coordinate going straight down of x2 and a y coordinate of y2. Okay, so then the length of this horizontal leg is just x2 minus x1. It's large minus small. If you want to have a positive length, right? Take the right value minus the left value for a positive length. And the length of this leg, right, the vertical leg, is y2 minus y1. Right, again, now for on the y-axis, if you want a positive length, you do large minus small, top minus bottom, y2 minus y1. So the legs have these lengths, and I'm going to call the length of the hypotenuse d, capital D, for distance. All right, this is the distance we're trying to find, the distance between A and B. And by the Pythagorean theorem, the hypotenuse squared will be equal to the leg, the horizontal leg, x2 minus x1 squared, right, plus the other leg, the vertical leg squared, which has a length of y2 minus y1 squared. Right. Now that's the distance squared. Right. I want just the distance though, so I take the square root of both sides, and we get the distance between these points. Now it could be the positive square root or the negative square root, but because we're talking about a length, we're going to just do the positive square root. So the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. And this right here, put it in a different colored box here, this right here, this is the distance formula. Alright, so if one point has coordinates x1, y1, the other point on the other end that you're trying to find the distance between has coordinates x2, y2, this is how you calculate the distance. And of course you're going to simplify things. Alright, so the example they gave us, was the points, find the distance between the points -4, -5, and 2, 5. Right. Now you can do this a couple ways actually. If you could draw a picture, you don't have to. You can always just use the formula, but here's a rough sketch of the xy plane. Now I'm not going to put little notches. I'm just going to label the axes. So -4 on the x-axis, -5 on the y. That's left and down. That's this point here. And then 2, 5 is 2 to the right, 5 up. Right, that's this point here. and then I'll draw the little right triangle that I did earlier, right? Like I can make a little right triangle like this. Right? Now this distance here is going from, the horizontal leg. You're going from -4 to 2. That's 6 units. And then the vertical leg, you're going from -5 to +5. That's 10 units. And then the hypotenuse, I'm calling the distance d. Right? We have d squared. Right? The hypotenuse squared equals 6 squared. That's the length of the horizontal leg. Plus 10 squared. That's the length of the vertical leg squared. This is 136. Right? 100 plus 36. So d squared equals 136. But that, again, that's just d. D squared. Sorry, I want d. So d is the square root of 136. Now they did ask us to simplify this, right? Simplify the radical. So hopefully you remember how to do that, right? If there are any factors of 136 that are perfect squares, you should factor them out and then take the square root of that and use the product rule for radicals. Now let's see, if I break down 136 is 2 times 68. And 120 plus 16, yeah, and this is 2 times 34. This is 2 times 17. So I have two 2's, right? This is 4 times 34. This is the square root of 4 times the square root of 34, and the square root of 4 is a nice perfect square. That's just 2. So when I simplify the radical, it's 2 times the square root of 34. Right. Now if you want a little, figure out, hey, what is that really? This is between, 121 and 144. 121 is 11 squared, 144 is 12 squared. This is between 11 and 12 units. It's 11 point something. All right, so this distance is 2 times the square root of 34, which is somewhere between 11 and 12 units. That's the distance between these 2 points. But they want us to enter it this way. Now, that was with a nice picture and everything. You could just use the formula, right? Or just use the formula, right? Label your points. One end I have x1, y1. The other end I have x2, y2. And then go into the formula. The distance is the square root. Make a big square root, right, like up here. And then in parentheses you have x2 minus x1. 2 minus -4. And then square that. Plus, and then the next set of parentheses, y2 minus y1, 5 minus -5. Now don't forget, when you're subtracting a negative, it ends up being adding. So we have the square root of 2 minus -4 is 6, so you have 6 squared. 5 minus -5 is 5 plus 5, that's 10. And it's exactly the same thing as earlier. It's 6 squared plus 10 squared, right? I got 6 squared plus 10 squared earlier, 136. And the square root of 136 is the square root of 4 times the square root of 34. Square root of 4 is 2. So that's 2 times the square root of 34. Somewhere between, these are something between 11 and 12 units apart. 11 point some units apart. But they want us to enter the simplified radical form. So 2 times the square root, let me just use it, there's the square root symbol here, of 34. Right? And that was it, the simplest radical form. Okay, wonderful. So yeah, you can draw a picture like I did, or just use the formula. Totally fine either way to find the distance between 2 points. All right, and again, just read through the answer explanations, please. All right, next question. Another distance formula question. So I'm just going to keep the formula up and we'll look at the distance between the points 6, -3, and 4, 3. All right, so back to my paper. The distance between 6, -3, and 4, +3. So again, if you want to label them, that's x1, y1. This is x2, y2. And I'll just jump to the formula. All right, the distance between them will be this, again, big square root, and then in parentheses I do x2 minus x1, 4 minus 6 squared. So it'll end up being positive anyway because you're squaring. Plus, and then y2 minus y1, 3 minus negative 3. All right, 3 minus negative 3 squared. So this is the square root of. Now, negative 2 squared is positive 4. And 3 minus negative 3 is 3 plus 3, that's 6. And 6 squared is 36. So we get the square root of 40. Alright, so this is between 6 and 7 units, right? Because 36 is 6 squared, 49 is 7 squared. This is between those. This is between 6 and 7 units apart. Now, we have to simplify though. And the square root of 40 is the square root of 4 times the square root of 10, which is 2 times the square root of 10, right? And 10 doesn't have any perfect squares that go into it evenly, so this is considered totally simplified. And again, you can draw a picture if you want. Be my guest, right? Draw a little right triangle, find that horizontal leg, the vertical leg, and then use the Pythagorean theorem to find the hypotenuse. But it would be this anyway, 2 times the square root of 10. Alright, 2 times, now I think you can just do backslash, oh, no. I think you can do backslash and SQRT. Nope, that doesn't work either. Alright, so this, guess you just got to use this little square root in the keyboard down here, square root symbol. 2 times the square root of 10. And that should be good. Wonderful. Again, please read through the answer explanations. Alright, now we're back to the objective on using the midpoint formula. So let me bring that one back. So now we're asked to find the midpoint of the line segment with endpoints 7, 5, and negative 6, 3. Alright, so remember, midpoint formula was very simple, I feel. If you know the endpoints, the midpoint, the x-coordinate and y-coordinate are just the averages of the x-coordinates and y-coordinates of the endpoints. So here we're given endpoints of a segment that are 7, 5, and negative 6, 3. And if you want to draw it, you can, but I'm not. Alright, x1, y1. Here's x2, y2. Then the midpoint, the point that's exactly halfway between them on this segment, again called M. The x-coordinate is the average of these x-coordinates. 7 plus negative 6, or 7 minus 6, same thing, divided by 2, comma. Then the y-coordinate of the midpoint is the average of the y-coordinates of the endpoints. 5 plus 3 divided by 2. And so we're getting, 7 plus negative 6 is 1. That's 1 half. 1 half. Or 0.5, something equivalent. You can write that too. 1 half for the x-coordinate of the midpoint. Then 5 plus 3 is 8. Divided by 2 is 4. And there you go. There's the coordinates of the midpoint. 1 half for x, 4 for y. And that's what I'm typing. Now notice they have the parentheses already. You're just filling in the coordinates here. So 1 half for x and 4 for y. Wonderful. All right. Next question. All right, still using the midpoint formula. So find the midpoint of the line segment with these endpoints. All right, so back to that. I'll just work on the same paper here. So the endpoints, I'll just write ends are at 7, negative 12, and negative 5, negative 15. And I'll just put mid for midpoint. Alright, so the x-coordinate of the midpoint is the average of the x-coordinates of the endpoint. 7 plus negative 5, or negative 5 plus 7, divided by 2. The y-coordinate of the midpoint is the average of the y-coordinates of the endpoints. Negative 12 plus negative 15, divided by 2. All right, 7 plus negative 5, that's 7 minus 5, that's 2. 2 divided by 2 is 1, so 1 is the x-coordinate of the midpoint. Negative 12 plus negative 15 is negative 27 divided by 2, and that doesn't simplify any further. So there you go. Now you can write a decimal if you want, as long as it's equivalent. That'd be negative 13.5. Right, negative 13.5, same thing, but that's as simple as that fraction's getting. So there we go. And again, we're just entering the coordinates, right? The x-coordinate is 1, the y-coordinate is negative 27 divided by 2. Right, negative 27 halves. Hooray. All right. Next. All right, so it looks like we got one more here on the midpoint formula. So I'm going to keep that same midpoint formula sheet up. Now this is one like the first one we saw where we have to move our point to where the midpoint is. But let's find the coordinates of the midpoint first. All right, so again here the ends, the end points, we're at negative 7, 4, and 0, negative 5. All right, so the midpoint, M, the x-coordinate is negative 7 plus 0 divided by 2, right, the average of the x-coordinates of the endpoints. And the y-coordinate would be 4 plus negative 5, then divided by 2, the average of the y-coordinates of the endpoints. This is just negative 7 halves. And then 4 plus negative 5 is negative 1, and that's negative 1 half. Now I think they have decimals showing up on this, so if you write these as decimals, that'd be negative 3.5, right? Negative 7 halves is negative 3.5. And negative 1 half is negative 0.5. So we're going to move our point in that graph to this point here. Negative 3.5 for x and negative 1.5. Alright, so negative 3.5 for x, and then down to negative 1.5. Or sorry, negative 0.5. I had negative 0.5. And there you go, that's on the segment. And it looks pretty good. It looks like that point is exactly the same distance from both ends. And great. Alright, and then the last, that's it for that objective, and there's only the one other objective. So the last remaining problem should be on the distance between 2 points. Alright, so once again I'll go back to that distance formula sheet, and we'll just write up these points we're given and find the distance between them. And again, we want to give our final answer in simplest radical form. Alright, so here was the distance formula again. And we're finding the distance between negative 4, negative 9, and negative 8, 1. So again, if you want to label them x1, y1, x2, y2, you can, right? And then the distance would be equal to the, make a big square root. And then in the first set of parentheses, you're taking the, change in x, negative 8 minus negative 4. The second x-coordinate minus the first one, negative 8 minus negative 4, and then you're going to square that. Plus, and then another set of parentheses, 1 minus negative 9. Right, the change in the y-coordinates, subtract the y-coordinates, and then square that. And make sure all of this is underneath the square root. Okay, so negative 8 minus negative 4, that's negative 8 plus 4. That's negative 4. Right? And you're going to be squaring that, which will be positive 16 in a second. 1 minus negative 9 is 1 plus 9. That's 10. Right? And then you're going to be squaring that. So this is the square root of 116. Right? Negative 4 squared is 16. Positive 16. Plus 10 squared is 100. Alright, and then once again, this is going to be broken up. The square root of 4 times the square root of 29. Alright, 4 times 80 plus 36, 116, yeah. And 29 doesn't break down any further, so there's no way to reduce that. And the square root of 4 is nice, right? That's 2. And so this ends up being 2 times the square root of 29 when you're totally simplified. And if you want, you can point out that this is between 10 and 11 units. Right, so these 2 points are between 10 and 11 units apart, if they ever asked for some reason. Because 100 is 10 squared, 121 is 11 squared, and this is between those. And this is what I'm entering, right? What I'm pointing to here, the simplified radical form. So 2 times the square root of 29. Great. Alright, I should have just one final question from this objective, and it's the same thing. Find the distance between these 2 points. Enter your answer in simplest radical form. Do not round, right? Don't enter it into a calculator. Alright, so let's turn this page over. Keep the same formula up. What's the distance between the points -4, -5, and the point 0, -1? Alright, so again, the distance is the big square root. Subtract the x coordinates, 0 minus -4, and then square that. Plus, subtract the y coordinates, -1 minus -5, and then square that. And again, make sure all of that is underneath the square root symbol. Alright, 0 minus -4, that's 0 plus 4, that's 4. 4 squared is 16. Plus -1 minus -5, that'd be -1 plus 5, which would be 4. 4 squared is 16 again. So this is the square root of 32. Alright, 16 plus 16, which, this is the square root of 16 times the square root of 2. 4 times the square root of 2 when you totally simplify. 16 is a nice perfect square that goes into 32 evenly. And again, if you want to think about it, right, this is between 5 and 6. Right, so these 2 points are between 5 and 6 units apart on the xy coordinate plane. Right, because 25 is 5 squared, 36 is 6 squared, and this is between those. Right? 32 is between 25 and 36. All right, and then this is what I'm going to enter, though, the 4 root 2. So we have 4 times the square root of 2, and that should be good. Great. And again, you can draw a picture of a right triangle if you want. Find the horizontal leg, the vertical leg, use the Pythagorean theorem, or, like I've been doing here, just pop it into the formula. Alright, and that should be it for this preview of this assignment. And as I said at the top of the video, though, please understand that the questions I saw here, may not be the exact same questions you'll see when you're working on the assignment yourself. But the objectives are the same, right? The types of questions and how you approach them should be similar to what I've done. So I'm hoping that watching me, helps you in some way when you're doing the assignment yourself. And thank you very much for watching.